Having seen the concept and the methods to do matching, we are now going to look at what is matched analysis. In the conventional odds ratio that we use for adjustment of confounders, this is what we end up in doing, what is called Mandel-Hansel adjusted odds ratio, where you see AD and BC the top and bottom respectively. In the matched analysis for a set, for example, we have given here a pair of case and a control. We will have information on pairs who have said they are either exposed or unexposed. So therefore, they are called concordant pairs. When you look at this side, you can see when the pairs have said they both are exposed, there is no odds ratio emerging out of it. It shows no effect. On the other side, when both the pairs have said they are not exposed, you will end up in seeing no effect again. On the other hand, when you see discordant pairs, when the case and controls reported to have had different types of exposures. For example, on the left hand side, you see the case is exposed, the control is not exposed, and you see a positive association. On the right hand side, the cases are not exposed and control is exposed, therefore you see a negative association. And here ADs and BCs are input to the calculation. The Mandel-Hansel odds ratio therefore in a matched case control study becomes the matched odds ratio, wherein the numerator is in terms of number of discordant sets or number of pairs in case exposed and control not exposed, divided by the denominator number of discordant sets or pairs in which cases are unexposed but controls exposed. Therefore, the conventional 2x2 table that you see in a case control study, wherein columns represent cases and controls, the odds ratio of AD by BC becomes unrecognizable in a matched case control analysis. On the left hand side, you see cases, on the top you see controls. The columns are E, F and G and H. The F cell refers to the pair in which case is exposed, control unexposed. The cell G refers to cases unexposed but controls exposed, referring to the discordant pairs of different exposures in case and controls. Therefore, odds ratio in a matched case control study is F by G, or in other words, what we already said as number of discordant pairs in which cases are exposed, controls unexposed, divided by cases unexposed but controls exposed as the denominator. This is guided by the statistical test using chi-square, McNemus chi-square. We will now see how data management is done for matched studies. In matched case control studies, it is very important to have a link established between the sets or pairs of case and controls or exposed and unexposed in the design stage itself. This link is crucial in order to carry out analysis. For example, if it is a frequency matching, we may do a stratified analysis using the link. If it is a set matching, we may do a matched analysis using the sets using the link. We may do a paired analysis in a case control study materializing on the link. Therefore, it is very important that this link is available in the data set in order to prepare for data analysis and carry out the data analysis. The link is the extra variable that has to be there in the data set. It is an identifier for each of the case control or exposed and unexposed stratum when it comes to frequency matching, a set when it comes to case control sets. When we say set, we are referring to more than 1:1. When it is 1:1, we are referring to as a pair of case and control. This identifier has to be there for each of the stratum or set or a pair. All the cases and controls or all the exposed and unexposed belonging to the same stratum or set or pair has to share the same value for the match set variable. Therefore, each stratum or set or the pair have a unique value. For example, in a matched set variable in case of frequency matching, let's say we did a case control study with frequency matching on neighborhood. We have used, for example, 20 different neighborhoods. Therefore, the variable neighborhood is the link. The neighborhood variable takes values between 1 to 20. The neighborhood variable may itself serve as a matched set variable. Therefore, all case and sets belonging to, let's say, neighborhood value of 1 will share the same value for the neighborhood variable. Each neighborhood will have unique number. Creation of a separate, special or the extra variable may not be necessary. We need to have the neighborhood variable as a materialized link for carrying out matched analysis when it comes to frequency matching. In case of set matching, say for example, we have done a case control study wherein we have matched for age, gender and socioeconomic status, and we have also decided on 1:3 ratio, which means for each case we recruit 3 controls, and then we need to make sure each case defines the set. Therefore, each control for that set will be assigned the same number as that of the case. We need a special variable called set variable. Each case defines a set number. The 3 controls assigned to each case will share the unique value for that set number. For example, if it is set 1 wherein the case status is indicated as 1, the control status is indicated as 2, 2, 2 for that set number 1, and for the set number 2 similarly the case status is 1 and the rest of the 3 cases get the status of 2, 2, 2, which is control. Therefore, there are 2 sets in this slide, and we are talking about set as the link variable when it comes to matched case control study involving sets. When it comes to pairs, for example, if we match each case with that of a control matched by age, gender and socioeconomic status, we are talking about pairs. There are cases, each case defines a pair and each control is assigned to a pair with one of the cases. Therefore, we need a special variable called pair. That pair variable takes value from the case. The control is assigned to each case will also take the same value as that of the case. For example, in this slide you can see that there are 4 pairs of case and controls. You can see there are 4 pairs 1, 2, 3 and 4, and each of the pairs have the case and controls indicated in the column status. The variable pair is the materialized link for this matched analysis of pair case control study. The matching variable, as we discussed, is indispensable to the matched analysis. For frequency matching, as we discussed, it's crucial to do stratified analysis wherein we will use this particular matching variable for doing stratified analysis. In the set matching, when we do matched analysis, the matched exposure and outcome is analyzed by this set variable. In the pair matching, the matched analysis is done using the matched exposure and outcome by this pair variable. Thank you very much.